Hello guys, welcome to Unacademy Studios Bridge. This is the team of Unacademy Studios Bridge that keeps bringing the learning videos every single day for you. And I'm Marut Tiwari. I did my masters from IIT Kharagpur. I'm an IITian, not only IITian but also a topper there. I've cracked GATE for multiple times and I'm also an author of the book GATE in 75 Days. Follow me at marutlife-4661 on Unacademy Learning app to keep getting updated regarding all my free special classes and all my Unacademy Plus courses that I'm gonna launch for 2021 GATE and ESE entrance exams. So today we are going to continue this GATE question series where we're going to discuss about complex stress. But before we do this, if you have still not subscribed for Unacademy Plus, then I would rather recommend you to do this. Why? Because that's the best way to prepare for GATE and that's the best way to prepare for ESE. My dear friends, you get so many advantages. You can experience Plus for free and you can follow flexible schedule. You can attend the sessions in the language of your choice and you can do unlimited practice. As much practice as you want. As many times as you want, you can see. And then while attending the live classes, you can chat with the educator. You see, here is the chat. So here is the educator. Here is the educator. This is how it looks. This is the educator and this is the content that the educator is going to teach. And then you have the comments. Then you have the chat here. So you can chat with the educator, you can participate in interactive polls, you can learn anytime and anywhere. There are so many packages available. Monthly package is there, 3 months package is there, 6 months package is there, and 12 months package is there, 24 months package is there. If you go for 12 months package, it's going to cost 25,000. If you go for 24 months package, it's going to cost 40,000. But if you use my code MTLive, then you get 10% additional discount. If you use the code MTLive, then you get 10% additional discount. So go ahead, install the Unacademy Learning app and choose GATE or ESE as your goal and then select a convenient package. And before subscribing, use my code MTLive. Why? You can learn online so many things for free, no? Is it a compulsory thing? Is it a necessary thing? Is it essential to subscribe for Unacademy Plus? And what is the advantage that you're going to get by doing so? Number one, that with respect to offline classes, you're going to get a lot of convenience. You can avoid traveling expenses, you can avoid hostel expenses, you can avoid, wasting your time in traveling up and down daily basis, and you can even avoid wasting the time to be well in advance to occupy the front row seats. So there are so many wastages of your resources that you can avoid. Number two, that my dear friends, you get top quality educators here. I myself am going to take engineering mechanics, SOM, MD, TOM and FM, these 5 subjects for both GATE and ESE platforms. For GATE as well as for ESE platforms, I'm going to teach both these subjects and I'm going to take an assurance of covering all possible variety of problems. So make sure that you go ahead and subscribe for the things. Now, let us discuss about the topic. So today we are going to discuss about complex stress. As far as complex stress is concerned, my dear friends, first thing that you got to know is that at any given point, stress is going to vary with plane. Stress is going to vary with angle. For example, at this given point of the loaded body, if you select this black element, then you get some, let's say, sigma x and sigma y and tau xy. But at the very same point, At the very same point, if you select some different angle, then you get some different values, sigma x dash, sigma y dash, and tau x dash y dash. So if you go to some other angle, you get entirely different values, but luckily you can express them in terms of these black values. And these equations are known by the name transformation equations. These equations are known by the name transformation equations. Kindly remember them. Sigma x dash and sigma y dash. Sigma y dash is gonna be sigma x plus sigma y by 2 and sigma x minus sigma y by 2 cos 2 theta and tau xy sin 2 theta, and even the shear stress in that red system can be expressed in terms of the values of the black system, something like this. What do we call them? We call them transformation equations. We call these equations by the name transformation equations, and these transformation equations are going to be very useful, so please make sure that you mug them up, you absorb them up totally. Okay, so these are the transformation equations and you must remember them, and you must also remember that theta will be treated for theta. I'll clarify theta later. First of all, let me tell you that because stress changes with angle, at one single point, stress keeps changing with orientation. You go to one angle, you get one set of values. You go to some other angle, you get other set of values. Every single value is going to get changed. Every single value is going to get changed. And you can express them like this. So if stress changes with orientation, at some spatial orientation, you get maximum possible normal stress. And that spatial orientation is known by the name principal plane. That spatial orientation is known by the name principal plane. At some spatial orientation, you get maximum possible normal stress value, and that spatial plane is known by the name principal plane. Okay, this is what you have, and this is going to be theta star. This is going to be theta star. How do you determine this? How do you determine that where exactly principal plane is going to happen? Where exactly principal plane is going to happen? How do you determine this? I'll tell you. Here is the formula to determine the angle of principal plane. Tau xy divided by sigma x minus sigma y by 2. And how do you determine the principal stress values themselves? The principal stress values are going to be sigma average plus r and sigma average minus r, where sigma average is what? Sigma average is sigma x plus sigma y by 2, and r is what? R is sigma x minus sigma y by 2 whole square plus tau xy square. So I repeat once again for one more time that at one single point, stress keeps changing with angle. At some spatial angle, sigma becomes maximum, and that spatial angle is known by the name principal plane. Okay, that spatial orientation is known by the name principal plane. How do you determine the principal plane angle? Here is how you do that. And what about the principal stress formulas? They are sigma average plus r and sigma average minus r. And please remember all this. Now, tau max. somewhere even the shear stress will become maximum. Somewhere even the shear stress will become maximum. And I will tell you the shear stress maximum value for general case, okay? I'll tell you the shear stress maximum value for general case. For general case, the shear stress maximum value is sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, and sigma 3 minus sigma 1 by 2. Out of these three values, you must select the maximum value. Out of these three values, you must select the maximum value. 1 minus 2, 2 minus 3, and 3 minus 1. Out of these three values, you must select the maximum value. Now listen very attentively. Even if sigma 3 is 0, you are still going to use this tau max formula only. Even if sigma 3 is 0, you will use the first one only when they say in plane maximum shear. Only when they say in plane maximum shear, then my dear friends, you're going to use the first one. Otherwise, you're always going to use all the three values and then you're going to select the greatest value. Then you're going to select the greatest value. Out of these three values, you're going to select the greatest value. Now let's start solving the problem. You see, just now I explained maximum shear stress formula. And just now we have the problem. This is a 1-mark problem they asked in 2009. The problem says that we have sigma 1 and we have sigma 2 and there is no sigma 3. We have sigma 1 given, sigma 2 given, there is no sigma 3 given. So sigma 3 by default becomes 0. They are asking tau max. They are asking tau max. So what would you calculate? 1 minus 2? Or are you going to calculate all the three values? 1 minus 2, 2 minus 3, 3 minus 1. You must calculate all the three values. Okay? You must calculate all the three values. Why? I told you, जब तक वो ये ना बोले, unless they are going to say in plane maximum shear. Unless they are going to say in plane maximum shear. Then you will have to calculate all the three values even if sigma 3 is 0. Even if sigma 3 is 0. Still you will have to calculate all the three values. So tau max is equal to first value and second value and third value. Out of these three values, maximum one is the third one, and that is nothing but 50. So second option is the correct option. Now, once again they are asking maximum shear stress. Once again they are asking maximum shear stress, but this time they are not giving you the principal stress values. They are giving you sigma x and sigma y. Sigma x is minus 200, sigma y is 100, and tau xy is 100. Sigma x is minus 200, sigma y is 100, and tau xy value is 100 again. So you'll have to calculate the, first of all, you'll have to calculate the principal stress values. Principal stress values are gonna be sigma average plus r and sigma average minus r, sigma average plus r and sigma average minus r. Now you put the values. If you put the values, then you get sigma 1 and sigma 2 values. So sigma x is what? Sigma x is minus 200, sigma y is 100, and here again r value is sigma x is minus 200, sigma y is 100, and what about tau xy? Tau xy is 100 again. Tau xy is 100 again. So what are the sigma 1 and sigma 2 values. Let me calculate them. Let me calculate the sigma 1 and sigma 2 values. We have minus 50, and then you're going to have 150 square plus 100 square under square root. Okay, so first value is 130.28 and the second value is gonna be sigma average plus R is 130.28. So sigma average minus R you'll have to calculate. I deleted it somehow. 150 square plus 100 square under square root and plus 50. This is minus 230.28. Okay, so you get the sigma 1 and sigma 2 values. What about sigma 3? Sigma 3 is 0. And by the way, I'm once again going to calculate all the values. 1 minus 2, 2 minus 3, 3 minus 1. Why? Because they are never saying in plane maximum shear. You're asking maximum shear stress. Only when they say in plane maximum shear, then you will have to calculate only one value. Sigma 1 minus sigma 2 divided by 2. Okay. So you'll have to calculate all the three values and then you go for maximum one. Here is a problem that they asked in 2016. A shaft with a circular cross section is subjected to pure twisting moment. Then ratio of maximum shear stress and largest principal stress. Easy problem. Why this is an easy problem? Because my dear friends, if it is subjected to a twisting moment, what it is going to experience? It is going to experience some shear stress. Look, it is going to experience some shear stress, isn't it? And if it is going to experience no normal stress, it is going to experience only some shear stress. Let's say it is K. I'm just giving it a value, okay? I'm just giving it a value K. I'm just calling it by a name K. Can you calculate principal values for this? Very easy. Sigma average plus R and sigma average minus R. Sigma average is x plus y by 2. R is x minus y by 2 whole square plus tau x y square. Now there is no sigma x, there is no sigma y, there is no sigma x, there is no sigma y, and tau x y is k. So sigma 1 and 2, they will be what? Plus minus k. Simple? Plus minus k. So sigma 1 is what? Sigma 1 is plus k. Sigma 2 is what? Sigma 2 is minus k. What about sigma 3 value? Naturally, this is a plane stress problem. So sigma 3 value is 0. Isn't it? Now you can calculate tau max. And tau max is gonna be maximum of 1 minus 2 by 2, 2 minus 3 by 2, and 3 minus 1 by 2. Now you will have k minus minus k divided by 2, and here you'll have minus k minus 0 divided by 2, here 0 minus k divided by 2. Now you see, you have k, 0.5k, 0.5k. You have k, 0.5k and 0.5k. So naturally, k is the greatest one. Now you tell me what is the ratio. of greatest normal stress and greatest shear stress. For pure torsional moment, they both are equal. Do remember this. For pure shear situation, when you have only shear and nothing else, then please remember this, that for pure shear situation, sigma max is equal to tau max. This is going to be a helpful funda. This is going to be a helpful funda. That for pure shear situation, sigma max and tau max both will be equal. For example, look at this problem. It is the same thing. It is the same thing, believe me. And how? I'll prove it, but first of all, let me solve it in fundamental way. For one system, sigma is given to you plus p and minus p, and there is no tau. And they are asking you to calculate the stress values at 45 degrees. At 45 degrees. This is given as 45 degrees, okay? So you can calculate it very easily. Just by looking at the first three equations I told. First three equations that I described, you can use them. Sigma x dash is equal to sigma x plus sigma y by 2, and I hope you remember sigma x minus sigma y by 2. And this is clockwise. Clockwise angle will be taken as negative, okay? Clockwise angle will be taken as negative. Then what is the tau here? There is no tau, 0. So tau is gone. What do you get? You get sigma x dash is equal to p and minus p, they are going to get cancelled. P plus p, 2p by 2. This will become p. Oh, cos 90 is 0. So this is not p, this is rather 0. This is rather 0. What do you get here? 0. Similarly, even sigma y dash you will get 0, and tau xy you will get equal to p. Tau xy you will get equal to p. Okay. Which equations am I using? I'm using these equations. Sigma x dash, sigma y dash, and tau x dash y dash. Just remember one thing, that I'm taking theta as minus 45. Why? Because clockwise angle. If you have clockwise angle, it will be taken as negative. If you have anti-clockwise angle, you'll be taking it as positive. Anti-clockwise, do remember, anti-clockwise theta will be treated as positive, and clockwise theta will be treated as negative. Okay, so this is what you get here. 0, 0 and p. You'll get 0, 0 and p. Okay, now here you have 2017 problem where there is no stress. Sigma x is 0, sigma y is 0, sigma z is 0, tau xz, tau zx, tau yz, tau zy, all of them are 0. All of them are 0. Only one tau is present. Only one tau is present. So it becomes pure shear, isn't it? It becomes pure shear if only one tau is present. And I told you something about pure shear. For pure shear, I told you something tricky. That for pure shear, sigma max and tau max will always be equal. For pure shear, sigma max and tau max, they will always be equal. So whatever is tau max, whatever is tau max, you'll get the same sigma max. If you know the concept, this problem you can solve just like that, just like in 2 seconds. If you know the concept, this problem you can solve just in 2 seconds. This is yet another problem they asked in 2018, and once again they are asking maximum shear stress. You see, maximum shear stress is difference of principal stresses divided by 2, and there is only one option where you see the difference. This is like, you know, free marks, free 1 marks you're getting if you just know the formula, because there is only one option where you have difference of principal stresses, and you know there is no root in the formula and all. So this was again a very easy problem. In the next session we'll be moving on to solve all these 2 marks problem, and in the next to next session we will be solving the problems based on Moore's circle. Thank you very much for staying tuned. I just hope you guys enjoyed the session, and I just hope that I'm able to, from my side, whatever efforts I'm putting in, I'm able to enhance your learning a little bit. So with this hope, I'll keep trying, and you should also keep subscribing for the things, and also do like the video if it has helped you in gaining by even 1%, then do like the video. And whenever you're going to subscribe for Unacademy Plus courses, use my code MTLive to get 10% additional discount. And my dear friends, this is something that I want to share, that if you are going to subscribe using my code, then I'm going to mentor you. I'm personally going to mentor you. I'm not only going to teach mechanics, SOM, TOM, MD and FM on Unacademy Learning app, but I'm personally going to mentor you throughout the year with all your personal queries, with all your personal doubts, with all your tips and tricks and tricks and strategies, by keeping you in my personal mentorship. So use my code, and once you use my code, do tell that to me, so that I can keep you in my personal mentorship for GATE 2021 or for AC 2021. Thank you very much. Keep learning, keep enjoying, keep rocking. Thank you. Let's crack it.